Good day, it's Miss Lynn Sison. I'm coming to you with just some information about force and acceleration. So we've been talking extensively about forces and Newton's laws. So now we're ready to to calculate net force. So that's what we're going to be focusing on today. It's very simple. Let's go ahead and get started then. All right, so what we're really looking at today is Newton's second law. So Newton's second law is called the law of acceleration. We've talked about this one already. So it's an object the acceleration of an object is directly proportional to the net force acting on an object and inversely proportional to the mass. So that's why it's called the law of acceleration, and it's expressed in this formula. F equals ma. So this formula probably looks pretty familiar to you. You probably have heard of it before. It's sort of a normal thing. The amount of force you have to use to move something is directly proportional to its mass, the amount of matter it's made up of, and how fast you want it to go, the acceleration. So what's different about throwing a ball horizontally as hard as you can and tossing it gently? When you throw it hard, you're going to exert a much greater force on the ball. So whether you're thinking you're familiar with baseball or soccer or football or golf or really any kind of force it's played with, any kind of sport played with the ball, it's all the same. If you want it to go faster, you have to put more force on it. The hard thrown ball has a greater change in velocity, and as we know, change in velocity is acceleration. So it's either a change in the speed of an object or the direction of the object or both. And this change occurs over a shorter period of time. Recall that acceleration is a change in velocity divided by the time it takes for the change to occur. So we've looked at acceleration a lot already. So this is just a different way to look at acceleration. So a hard thrown ball has a greater acceleration than a gently thrown ball. Because the harder thrown ball is more force is put on it, and the mass of the ball doesn't change. The ball still weighs 1 kilogram or whatever the particular ball weighs. So the harder you throw it, the more it's going to accelerate. If you throw a softball and a baseball as hard as you can, why don't you have the same speed? Well, the differences would be, if you're familiar with baseball or softball, either one, a baseball is a much smaller sphere that has a greater mass than the mass of the much larger softball. That's why it's called a softball, because it doesn't have as much mass. So if you put the same amount of force on it, it's not going to hurt as hard when it's thrown, or when it hits you, I guess. If it takes the same amount of time to throw both balls, a softball would have less. Force, mass, and acceleration are all related. The acceleration of an object depends on its mass as well as the force that's exerted on it. Newton's second law can also be used to calculate the net force if the mass and acceleration are known. If you do this, the equation for Newton's second law must be solved for the net force, or F. Typically, when I talk about net force, I'm probably going to put F and then in subscript net. All right, so here's the formula, and this is the triangle. Basically, if you want to know the acceleration, you're going to divide the force, the net force, divided by the mass. And it's expressed in the triangle. Force equals mass times acceleration, or acceleration times mass. Those are interchangeable. As we have been doing, force is going to be in newtons, mass is going to be in kilograms, and acceleration will be in meters per second squared. So these are all units that we've already been dealing with. So here's just three just quick examples. So if you have what force would be used would be required to accelerate a 40 kilogram mass by 4 meters per second. So the little sticker here, the little smiley face, is used to cover up the one that we're solving for. So if we know the force, if we're looking for the force, and we know the mass and acceleration, we know that on the bottom of that triangle, we're just going to multiply if we know both mass and acceleration. So your work would be 40 kilograms times 40 meters per second squared equals 160 newtons. One thing, and this was on that the Newton's Laws escape room that we did, you saw, instead of it being newtons, you saw it written like this. Oh no, this is not working. Oh, help if I... Whoops. All right, sorry, y'all. I think I got it now. Okay, you would see it written as kg times meters per second squared. And where that comes from is the kilograms here and the meters per second squared. Because remember, a newton is the amount of force it takes to accelerate a 1 kilogram mass at 1 meters per second squared. So these units, newtons and kgms, those are equivalent. So typically we're going to use newtons because it's just sort of the shorthand, but I wanted you to be familiar with this. If you ever see this, this is what a newton is equal to. All right, so now if we have a situation where we have a 4 kilogram shot put is thrown with 30 newtons of force, what is its acceleration? So now we're looking for acceleration. We know the force is 4 kilograms. We know the mass is 4 kilograms and the force is 30 newtons. To set that up, since force is equal to mass times acceleration, to calculate acceleration, we're going to divide the force by the mass. So 30 newtons, that's our force, divided by 4 kilograms of mass gives us 7.5 meters per second squared. So if you have this mass, this 4 kilogram mass, and you put 30 newtons of force on it, you're going to get an acceleration of 7.5 meters per second every second, or 45 meters per second squared. All right, one last one. So this one is kind of a little bit different. I'm not going to ask you to do any of these right now, but it tells you that Miss J weighs 557 newtons. What is her mass? So in this situation, we know that force is essentially, we're looking for the weight, which is 557 newtons. We want to know what her mass is. And for acceleration, since weight is the force of gravity, we're going to use our acceleration at 9.8 meters per second squared, because that is the acceleration due to gravity. So we're going to take that 557 newtons and divide it by 9.8 meters per second squared, which is going to give us a Miss J a mass of 56.8 kilograms, which it's about 130 pounds or something like that, like a normal weight for an average weight for a woman. All right, so that's it. And this is just a little background information for you. We've already looked at this in a couple of different situations, but here's just some background information on calculating acceleration if you know mass and force. All right, have a great day.